It's interesting, this idea of the Big Bang creating the universe. That's what Einstein's theory says. That's textbook cosmology, if you like. But the current textbook picture suggests that there was a phase in the universe's life before the Big Bang. If you define the Big Bang as the hot, dense phase from which the universe appeared to sort of burst 13.8 billion years ago, then that phase before it is called inflation. What we think happened is that before the Big Bang, the universe was accelerating exponentially fast. It means it was doubling and doubling and doubling in size. The numbers are ridiculous. If you started with a universe that was smaller than a single atom, then it would be, by a long way, bigger than the whole observable universe with 350 billion galaxies in it, and all of this happened in less than a millionth of a second. This was a very rapid, exponentially fast expansion. When that stopped, all the energy that was driving that expansion got dumped into space, heated it up, and produced the particles of matter out of which we are made and all the things we see out there in the sky. That is what we see as the Big Bang. That may sound fanciful, but that's standard cosmology at the moment. The big questions then arise. What started inflation? What stops inflation? How long did inflation go on for? The answer is, we're not sure. We don't know. In the beginning, there was an infinitely dense, tiny ball of matter that started to expand and would eventually give rise to the atoms, molecules, stars, and galaxies we see today. But what was there before the Big Bang? What was the state of the universe before? Well, the universe underwent a breathtaking cosmic expansion, doubling in size at least 80 times in a fraction of a second. This rapid inflation, fueled by a mysterious form of energy that permeated empty space itself, left the universe desolate and cold. Only after that did the hot, dense conditions of the Big Bang emerge. Some theories suggest that inflation doesn't stop all at once, it stops in patches. Every time it stops, you get a universe. Some of these theories, called eternal inflation theories, suggest that there may not be just our universe, the bit that we can see, but many universes, perhaps even an infinite number of them, and they may be produced all the time. So what do we make of that? Well, that's where modern cosmology is. If cosmic inflation correctly describes what happened before the Big Bang, it may push the ultimate answer to the question of where we came from beyond the reach of science. But that just pushes the question further because we don't know anything about what came before inflation, and it's doubtful that we ever will. There are now theories that suggest, as I mentioned, that there may be more than one universe, potentially an infinite number. It's a mind-boggling idea, isn't it? Now, I should say one extra thing. If that's true, then some of those theories suggest that what we call the constants of nature, such as the strength of gravity, the speed of light, and the masses of particles, can vary from universe to universe. This leads to the question, why is our universe so perfect for life? Why do stars make carbon and oxygen, the elements necessary for life? Why is everything so beautifully balanced so that living things can exist? The answer in these cases is that every universe exists. Every possible combination of the laws of nature exists in different universes. The reason we see a universe that allows us to exist is simply because we have to exist to observe it. Then we ask the question, how likely is that? If the answer is that there are an infinite number of universes, then it's inevitable because every possible kind of universe exists somewhere. I stress that this is very speculative stuff. However, the first thing I said about inflation, that there was an exponentially fast expansion before the Big Bang, is not speculative. That is mainstream cosmology. The idea that inflation may lead to multiple universes is more speculative, but it is still scientifically valid, and researchers actively study it. This remains an active area of research. Inflation tells us that the period before the Big Bang was extremely cold and empty, except for space itself, which carried energy that stretched the universe to its enormous size and into its initial state before the Big Bang. But there are also alternative theories to cosmological inflation that attempt to explain what caused the initial conditions that eventually gave rise to the Big Bang. One such theory suggests that there may be extra dimensions in the universe. Imagine that we are living on a sheet of paper. In some theories, our universe is just one of many sheets floating around in a higher dimensional space. If another universe, another sheet, exists nearby, what happens if they collide? One theory proposes that the Big Bang was actually caused by two of these sheets or branes colliding and then separating. When they collide, they heat up, and that process could create something that looks like a Big Bang on that sheet of space and time. This is yet another theory of what might have happened before the Big Bang, branes colliding, leading to multiple Big Bangs and a multiverse. These statements may seem extremely speculative and disconnected from reality, but they are backed by mathematical reasoning. Moreover, theories describing the very early state of the universe do have experimental support. The wonderful thing is that we are now making measurements to test them. The experimental basis for these ideas comes from something called the cosmic microwave background radiation, CMB. By looking up into the sky, we can see the oldest light in the universe, which was released 380,000 years after the Big Bang, when the universe cooled enough for atoms to form. At that point, the universe became transparent, and that light has been traveling ever since. We currently have a European satellite called Planck, which has been taking highly detailed pictures of this light. It's like a baby picture of the universe, a scan of the universe in its infancy. By analyzing this light, we can learn about the early universe and find clues about what happened at the beginning of time. This is where these theories gain their experimental support. The twin pillars of modern physics are Einstein's general relativity and quantum theory. To fully understand how the Big Bang emerged and what came before it, we must unite Einstein's theory with quantum theory. Only by developing such a unified theory will we be able to answer the ultimate questions in cosmology. What is space? What is time? What is the universe? And where did it come from? The most distant objects in the universe are 47 billion light-years away, making the observable universe 94 billion light-years across. If you're wondering how the observable universe can be larger than the distance light has traveled over the age of a universe, the answer is that the universe has been expanding all this time. This expansion causes distant objects to be much farther away than their light travel time alone would suggest. Most scientists believe that the universe extends far beyond what we can observe. But is there anything beyond the entirety of the universe? Probably not. Many suspect that our universe could be infinite in extent even now. The observable universe is just a small part of the whole. Why do we think that? Because measurements of how the universe is curved and structured strongly suggest that it extends far beyond the bubble we can see. Exactly how far is an open question, but it could be infinite. Taking into consideration the latest discoveries and measurements in physics, we have attempted to answer questions such as, what was there before the Big Bang? How big is our observable universe? What lies beyond the part we can see? But this naturally leads to another important question: how will the universe end? The best current estimate suggests that the universe will continue expanding forever.